Okay, I'm going to talk you through the level 1 exercise. So first of all, in each of these, you have to find the second derivative. So write out y equals, differentiate, and then differentiate again. For the second one there, just set it up right. Bring the x up as a minus 1. So it's x to the minus 1, minus 2. Bring that up as x to the minus 2. Differentiate it, then differentiate it again. And I would tidy up at the end. Number 3, write that as 2x to the half. Differentiate it. So power goes to front. 2 times the half is 1. Take 1 off. Then differentiate it again. So power to front, take 1 off. To tidy that up, it's minus 1 over 2. That x can go back in the bottom. The bottom of your fraction tells you it's the square root of x and then to the power of 3. Number 2, a curve has got this equation and you're looking for dy and d2y by dx squared. So differentiate it once, differentiate it twice. Find the coordinates of any turning point. So you take your dy by dx, put it equal to 0. To put that equal to 0, you factorise. So pull out your 3 and your x, put each bit equal to 0. Remember, you're finding points. So when you have your x worked out, sub it in to get your y. So 0 squared minus 3, 0 cubed minus 3, 0 squared plus 6. And then put it in your 2 when x is 2. So 2 cubed minus 3 times 2 squared adds 6. So you've got your x and your y coordinate. You always have to check the nature. So go to your second derivative. This one has got x equals 0. So put 0 in there. You'll see it's under 0, so it's a maximum. This one has got x equals 2, so put it into your second derivative, and you'll see it's positive, so it means it's a minimum. When you're sketching that, part 3 says sketch it, and just put on your important points. So at 0, go across 0 and up 6 to here is a maximum, so it's that shape. 2, 2 is a minimum, so it's that shape. Now you should find where it crosses the axes at, so you should be putting in here x equals 0 to get you your y intersection, and put y equals 0 to give your x intersection. But this question didn't ask it, so we'll not worry about that at this stage. But that is something that should be looked at. And number 3, a farmer has 100 metres of fence. So the total length of his fence is 100. He builds a pen. There you go. So I'll just write down the length. The length is 2y plus x, and that equals 100. So 100 metres. 100 is 2y plus x. So I can rearrange that to get y equals. So 100 minus x over 2 gives me y. And he wants to, let's say, which he intends to build. He intends rectangular pen. So show that the area equals this. So the area is the length times breadth, x times y. So x times y. And just tidying that up. So it's a half x times 100 minus x. That's what they wanted you to show. Then you have got differentiating that. So you could write that out if you want as, oh sorry, I did down here. Times that out, 50x minus a half x squared, differentiate it once. And then it wants you to differentiate it again. You differentiate that, it is under 0, so it's a maximum. So you don't have to sub anything in or do anything like that. And part 3, find the x, which makes it a maximum. So there's that key word, maximum. So you differentiate it, put it equal to 0. So there's your dy by dx, put it equal to 0, get your x. And you already know it's maximum because the second derivative is under 0.